So let's preview assignment 6, part 1. It says a certain brand of tissues has 60 tissues in a standard box because the manufacturers believe that this is the average number of times people blow their nose during a cold. A researcher of the company checking on the validity of this claim asked a random sample of 100 people to count the number of times they blow their nose during a cold. The mean of the sample was 57 and the standard deviation was 16. Do these data support the company's belief? Should the company continue to put 60 tissues in a box? Use a two-tailed hypothesis testing procedure with alpha of 0.05. Carry out all 9 steps of the hypothesis testing procedure. So let's first look at what information is given. We know that there's 60 tissues in a box. Okay. We're not quite sure what that is, but we also know that there's a sample of 100, so that would be your N. And then there's the mean sample of 57, so that would be your X bar. And the standard deviation was 16, so we know that that's your standard deviation related to the sample. Okay, so going back to the number 60 then, so we know the X bar, N, and S. So what's missing is the mu, right? So 60 is going to be my mu, and we know that that makes sense because it's a mean that's been known to us, not tested from a sample. That's just known information because that's what the company did, put 60, right? So we now have the mu and the X bar, 60 and 57 to compare. So given this information then, would you do a t-test or a z-test? Right? Depends on this information here and what's missing. What's missing is the standard deviation of the population. We don't know that information. Okay? So when we don't know that information, but we have the estimate, then we're going to do a t-test, right? So see if we can carry out the 9 steps, starting out with the HO and HA for step 1, and see if you can calculate for T obtained, set up a t-crit, and do a t-test in this case. In question 2, it says, assume that anxiety scores as measured by an anxiety assessment inventory are normally distributed with mu of 20 and standard deviation of the population of 4. So that's easy, right? The symbols are already there. A sample of 4 patients who are undergoing treatment for anxiety is randomly selected, and their mean anxiety score of X bar is 22. The question is the average anxiety score from patients who are under treatment significantly different from 20, the population mean? It says to assume alpha of 0.1. So what we know is mu is there and X bar is there. And this is a critical piece right here, right? The standard deviation of the population. Once we know that information, then we can decide which test to do. Would it be a t-test or a z-test? Because that information is known to us, we would do a z-test. And remember that the alpha is 0.1, so that's going to tell you what the cutoff is for the acceptance and the rejection regions. In question 3, it says, according to the National Association of Builders, the average single-family home size in the United States is normally distributed with a mean mu of 2392 square feet and a standard deviation sigma of 760 square feet. 16 single-family houses are randomly selected from Cleveland, and the mean size is 2,025 square feet. Is the average square footage of the houses in Cleveland different than the population mean? Assume alpha of 0.05. Okay? So we know the mu is there, the sigma is there, that's the population info. What is 2,025? Right? So it's a mean size of 16 single family houses, right? So this is going to be your X bar, and 16 becomes your N. Here's your alpha of 0.05. So in this case, would you do a t-test or a z-test? This is the critical piece right here, right? You have the standard deviation of the population. So when that information is known, you do a z-test. Using the alpha of 0.05 then, see if you can calculate to see if there's a mean difference between the population mean of 2392 and the sample mean of 2025. Let's preview for assignment 6, part 2. Number 4 says ACT composite scores are normally distributed with the mu of 21. A sample of 25 students is randomly selected from a local high school with an X bar, or the sample mean, of 23 and the standard deviation of 5.2. Do the data support the claim that the average ACT composite score of students from this high school is different than 21 on the ACT composite score using alpha of 0.05? All right, so let's look at what information is given. So mu is 21, sample is 25, so that's going to be your N. And you have your X bar and S, right? What is this? That's your standard deviation, not of the population, but of the estimated population, right? So using the alpha of 0.05 then, would you do a t-test or a z-test here? You would do a t-test, because the critical piece that's missing is this, right? The standard deviation of the population. That is not there. We do not have that information, so we would do a t-test in this case. In question 5, it says, nationwide, the average total amount of student loan debt in 2012 is normally distributed with the mu of $29,400. Assume that a sample of 36 students is randomly selected from a public university. Their student loans have X bar, or the sample mean, of 27,400, and the standard deviation of the estimated population of 9,000. It says to conduct a proper statistical procedure to test whether the average student loan in this public university is different from 29,400 using the alpha level of 0.1. So all the symbols are there, right? We have the mu, X bar, and the standard deviation of the estimated population. So, and we have the alpha. So what's missing here is this, right? That information is not there. And so would you do a t-test or a z-test in this case? You would do a t-test because this information is missing. And lastly, in question 6, it says SAT verbal scores are normally distributed with the mu of 500. A local high school has instituted a new program to engage students in reading. A sample of 9 students from this high school is randomly selected following their participation in this reading program, and their SAT verbal scores were reported. Here's the raw data for the 9 students. The question is the sample mean significantly different from the population mean? So in this question, unlike all the other questions, you have raw data. So we can assume that we have to do something with the raw data. What is given is the mu of 500. We also notice that there is no alpha given. So we know that we would start out with the alpha of 0.05. That's a good starting point. And we may decide to stay with that. Our ultimate goal is to try to reject a null. Or we could try the other 2 options. What else is given is the actual raw data. Now, we also know that from the raw data, we can calculate for X bar, right? The sample mean. And we can also calculate the standard deviation of the estimated population. Okay? So we can use the computational formula, because that's easier than the definitional, with the n-1 in the denominator. So once we have all this information, some preliminary calculations need to be done, right, with the sample. But once we have all this information, then we can proceed with the 9 steps, starting with the null hypothesis and the alternative hypothesis. So do we do a t-test here or a z-test here, given what we have? Again, the critical piece that's missing is the standard deviation of the population. It's missing. What we have instead is this estimate, right? So we're going to do a t-test to calculate. What we're going to then be able to measure is the difference between the population mean of 500 and the sample mean, whatever that calculation comes out to be.